Okay, so when we're talking about multiplication and division of powers, that means that you are having a value of the same base that you're multiplying by. So if I were to give you a problem like 2 to the 4th times 2 to the 5th, and I went ahead and I wrote it out long ways. So let's go ahead and just write this out in standard form. Let's start with 2 to the 4th. What would that look like in standard form? Colin? Good. 2 times 2 times 2 times 2, right? And then when we would go over to 2 to the 5th and write that out in standard form, that would just be 2 times 2 times 2 times 2 times 2. So I've written all of it out, and now I want to go ahead and simplify it back into exponential form. That would be 2 to what power? To the 9th power, right? So 2 to the 4th times 2 to the 5th gives us 2 to the 9th. Let's take a look at another one. If I were to say x to the 2nd times x to the 4th. Okay, well, x to the 2nd is just x times x. And then x to the 4th is just x times x times x times x. And if I were to write that in exponential form, it would become x to what power? To the 6th power. So what are you noticing from the original question to our answer? What is actually happening here, Justin? You're adding, not the powers, just the exponent. And what's still remaining the same then? Well, not always a variable, but what do we call this? We talked about it yesterday. You've got an exponent, and the exponent belongs to a what? The base, right? So the base is remaining the same. It's the exponents that are going to get added together. So that's the rule. The idea when you multiply powers, if they have the same base, they have to be identical bases. So if you're multiplying powers of the same base, all you're really doing is adding the exponents. Now, if this was 2 to the 4th times 3 to the 5th, I couldn't add those exponents. They're not the same base. Even if it was 2 to the 4th times negative 2 to the 5th, still can't do it because those are not the same base. A positive and a negative make them different. They have to be identical bases in order for you to be able to add the exponents when you're multiplying those powers. And a power, guys, is the whole thing written together. 2 to the 4th is called a power. 2 is the base, 4 is the exponent, 2 to the 4th is the power. So when you multiply powers of identical bases, you add their exponents. Let's write that rule down. God bless you. When you multiply powers of identical bases, you add the exponents. Okay, so let's take a look at a couple problems. Let's say that we've got x to the 3rd times x to the 7th. I don't want to have to write out all those x's. So instead, what I'm going to do is I'm going to keep my bases the same. The x will remain the same. It's the exponents that I'm going to combine together. So I'm just going to do 3 plus 7. And what is that going to give me? 10. So I get x to the 10th power. X to the 10th power. If I've got y to the fourth times y. What's my base? It's y. What are my exponents? 4 and 1. Remember, if the exponent is not written, there actually is an exponent of a 1 there. So we would do 4 plus 1, and this would now become y to the 5th power. Let's say we've got negative 7 x to the second times 11 x to the 5th. Negative 7 x to the second times 11 x to the 5th. Well, now I've got a couple things going on here. I've got some numbers here. So I've got a negative 7 and a positive 11. They're not the same bases, but can I actually multiply those?
Yes.
Yeah. So I'm going to go ahead and work that part out. I'm going to say, okay, well, negative 7 times 11, what is that going to give me? Negative 77. Good. So I've got negative 77 there. Then I'm going to go ahead and focus on multiplying the x squared and the x to the 5th. So if I've got x to the second times x to the 5th, what is that going to give me? Nope. X to the 7th. Remember, you add the exponents when they're the same base. So that gives me x to the 7th power. And that's my final answer. Okay, focus on the things that we can actually do. What's something we can do right now? Joshua? 2 times 8. Okay, those are bases, so you actually multiply them. What's 2 times 8? 16. Okay, now what can we work with? Colin? The m's. Okay, so we have m times m to the 5th. What is that going to give us? M to the 6th. Because that m has an exponent of a 1, and you're just going to add those exponents together. So that becomes m to the 6th. What else can we work with? W's. So we've got w to the 4th and w to the 6th. Very good. Good job, Mateo. So when we combine those, that's going to give us w to the 10th. So then there's our final answer. 16 m to the 6th, w to the 10th. All right, so I'm going to go ahead and have you guys do a couple of them on your own. Did you just oof? number was that I just finished with? Number 4? Okay. Okay, go ahead and try those on your own.
Is it x, y to the second power or just x and then y to the second power?
It's x and y to the second.
Oh. So it's just like x to the first power.
All right, who wants to tell me what they got for problem number 5? Jordan? X to the 12th power. Because all of the bases are the same, what you're actually going to be doing is just adding the exponents. So it's base x, and all the exponents get added. So it's 9 plus a 2 plus the 1. Don't forget that that x has an exponent of a 1. And then 9 plus 2 plus 1 gives you 12. So you get x to the 12th power. What about for problem 6? Who can tell me what they got there? Heaven? Very good. 42, x to the 4th, y to the 7th. Okay, so if you break it down on things that you can actually do, when you've got more than just one base occurring, you break it down. So here we've got the 2, the 3, and the 7 that we can actually work with. So we're going to do 2 times 3 times 7, and that's going to give us the 42. Then we've got the x's that we can work with. So we have x to the 3rd times the x. X to the 3rd times x to the 1st is going to give us x to the 4th. And then we've got the y's. Y to the 5th, y to the 2nd. So y to the 5th times y to the 2nd gives us y to the 7th. When we piece it all together, it's 42, x to the 4th, y to the 7th. And just so you guys know, the proper way to write your powers is to always put the number in front, then the variables in alphabetical order. It's always the number, the coefficient is going to go in the front, then the variables in alphabetical order will go next, okay? All right, what about for problem 7? What did you get for problem 7? Mateo? Very good. And you didn't even have to put power of 1 for the x. You could just say x. Yeah, and that's perfectly fine. So that's correct and good. I'm glad you caught the negative. So what we're doing is we're first going to focus on the coefficients. Negative 8 times 2 times 5. So negative 8 times 2 times 5 is going to give you a negative 40. I'm sorry, negative 80, my bad. Whew. Negative 80. Then you are going to focus on the w's, because again, alphabetical order is what you're wanting to go in. So you have w to the 3rd times w to the 2nd. So w to the 3rd times w to the 1st times w to the 2nd. You're actually adding all those exponents together, and that'll give you w to the 6th. Then you're going to focus on the x. That's the next proper order. Well, the x only occurs one time, so it's just going to be left as an x, or x to the 1st. And then you've got your y's. So you have y to the 4th times y, which is y to the 5th. Okay, if you piece it all together, your final answer is negative 80, w to the 6th, x, y to the 5th. And that's it. Any questions? Okay, so I don't want to give you guys the worksheet because the worksheet has division on there as well, but I want to go ahead and do the division tomorrow. So what I'm going to do is I'm just going to post up a couple of questions. It's just going to be 8 questions that you need to do tonight. We'll check it first thing in class tomorrow, but you're going to need to write them down. So go ahead and flip to the next page in your notebook. And I'm recording this. This is going to be loaded onto eClass, and I learned yesterday how to put it through Safari Montage so that if you're ever at school, you can view it from your devices or from the computers, and it won't block you from the YouTube channel. Okay? Well, yeah. All right. So you're going to simplify. I want you to simplify as far as you can. Meaning that if you have a numbered base, so like the problem might have said 2 to the 4th power, you're going to simplify 2 to the 4th power to its finalized answer. So you wouldn't leave it as 2 to the 4th. You would put it down as your answer of 16, right? Because 2 to the 4th equals 16. So simplify each expression as much as you can. So for example, 2 to the 4th is wrong. 16 is correct. All right? So if you get an answer of 2 to the fourth x to the second, it should be 16 x to the second. You guys got that? Don't leave any of your number bases in exponential form. Only leave your variables in exponential form. All right, so here we go. Copy them down, and you'll work on that tonight. Okay, once you've got it all copied down, you may go ahead and leave. And again, guys, if you get stuck on anything tonight, please make sure you send a picture to me. Don't just tell me you need help with number 5 or whatnot. Make sure you send a picture or text. And have a good day. And if you didn't bring your project in today, you need to bring it in tomorrow for a late grade.
Yeah, it's good. Dude, it's really good. Headshots, 210. It looks like a heavy. I'm dying right here.